The only two remaining problems that I have not talked about is problem 12 and 16 on homework number 3. So I'm going to work those out for you here on the video because I intended to work these out in class, but we weren't able to meet for class. So anyway, looking at the figure here on problem 12, homework 3, what it's asking you to do is to combine the resistors to get the equivalent resistance and then find the value of the power supply. They're asking you to figure out what the voltage is of this source using Kirchhoff's voltage law and Kirchhoff's current law, and you also have to use Ohm's law in there as well. Alright, so the first thing you do is combine all three of those resistors in parallel into one resistor, one equivalent resistance, and that is going to be, in this case, 2 ohms, and then you have this one in series with the other ones. So I'm just working this right out for you because this was supposed to be an in-class assignment. Then 5 plus 2 is 7. Now, that's one of the answers that you can kind of box for this one, but they're also asking you to find Vx, and the only thing they give you is that there's 1 amp going through this 5 ohm resistor. Now what that can tell you is that the voltage drop across this resistor, according to Ohm's law, is just I times R. So remember, Ohm's law is equal to V is equal to IR. And so the current is 1 amp. Resistance is 5 ohms, so that's just 5 volts. We can also use the rule that components that are in parallel have equal voltages. This is essentially the Kirchhoff voltage law, that if you have a voltage rise going this way, then it's going to be a drop over that way. Anyway, so this gives us the voltage drop across this one to be 5 volts. So little v is equal to 5 capital V. And then this one is also 5 volts as well. Now we don't know what this one is over here. If we did, that would really help us out in finding this one, because then we would have a rise and 2 drops, and that would be easy to figure out. So all you can really do is say that, well, these are equivalent to a 2 ohm resistor, so that means that the voltage drop across this equivalent circuit would also be 5 ohms. No, sorry, not 5 ohms. 5 volts. So the voltage is 5 volts. Now what can you do with that? Well, if you know what the drop is across this, if you measure it with a multimeter and got 5 volts, and you know what the resistance is, then you can figure out what the current is. But that's only the current going through this one, and it's going to be different than 1 amp because this is an equivalent circuit. So using Ohm's law again, it would be V divided by R, and the voltage is 5, the resistance is 2, so that's 5 halves of an amp. That means that a volt per ohm is just an amp. So that's the current going through that one. Now since these are in series, then that also means that the current going through this one is 5 halves as well. And in fact, that's the same as the current going through this over here. So now we have found the current through this equivalent circuit to be 5 halves of an amp. And then you have, if the current is going this way, you have a positive value there, negative value here. So using KVL, you have Vx, which is a positive value, and then you have a drop of 5 halves times 7 ohms. That's IR, the IR drop for this one right here, or that's our KVL loop. That's equal to 0. So that means that Vx is equal to 35 halves of a volt. An amp times an ohm is a volt. So our answer that goes down here in the bottom, 17.5 volts. So I worked this one out for you again because it is supposed to be an example problem in-class problem. That's what I intended this problem to be. The other one I did not work out in class is problem number 16. Problem number 16 looks like, well, here it is. And it's saying, suppose you have these four resistors, R1, 2, 3, and 4, and you apply 12 volts across there. So you have to add this to the drawing because that's what the problem says right here. And it asks you to kind of make a table of, well, what are the voltage drops across each one of these resistors. So we're going to do that now. The first step to do is to combine these in parallel and those in parallel to get two in series. So the parallel combination of the 100 ohm and the 50 ohm resistor gave us 33 1/3 ohms. Forgot my units. And then the resistor combination of the 75 ohm and the 25 ohm gives us 18.75 even. And again, we label our 12 volt power supply. You might notice there's a little different symbol than a battery. This is like the blue power supplies we have in lab. Still DC, but different circuit symbol. Equivalent circuit to that would just be a single resistance or a single resistor connected to the 12 volt power supply, 52.083, repeating 3 ohms. Since you know the equivalent resistance and the voltage of the source, you can find the current through the circuit, at least through this equivalent circuit, and that's going to be equal to V divided by R, which is 12 volts divided by that, so our current is 0.2304 amps. So go ahead and write all of this down in the solution. We're still not quite done yet because we're supposed to come up with this table over here to figure out what the voltage drops are across all four of those. So really what you do is you kind of work your way down to the simplest circuit, and then you kind of work your way back, because you see that the current through this leg would be equivalent to the current through that. So this also has to be equal to 0.2304 amps, just like it was for this problem here. Alright, well then you know what the voltage drop is across this one, because V is equal to IR. And so you just take this I and that R right there, and you get 4.32 volts. You do the same thing for this one. Since the current through this one is 0.2304, it's in series with this one, so the current through that one is going to be the same. And so the voltage drop across this one is that I times this R. And so for this one you get 7.68 volts. You might notice that this number plus that number equals 12. So we have a rise of 12 volts, a drop, as we have the current, have the current going the wrong way. I really should have had it go this way. So the current comes around like that, positive, negative, positive, negative, so we have rise and a drop and a drop. Now, how do you wrap up the problem? How do you get from this over to the original circuit? It's not too difficult, because remember that these two combine to give us that one, and since they're in parallel, the voltage drops across them should be the same. So for R3 and R4, we can come down here and say that the voltage is 4.32 volts. And these two are in parallel, which was equivalent to that resistor right there, 7.68 volts. So somewhat of a complicated problem. You have to kind of melt it down and then rebuild it just to get to the answer. But that's the simplest way to do it, using Kirchhoff's laws.